Here I have a SAT math question. Okay, let's go with the information. The area of a rectangle decreases by 9 square units if its length is reduced by 5 units and its width is increased by 3 units. If the length is increased by 3 units and the width is increased by 2 units, the area increases by 67 square units. What is the length of the rectangle? Okay, now we can assume some variables as the original length and the original width of the rectangle. So let me say that x is the original length of the rectangle. Let me write the stuff over here. So x represents the original length of the rectangle and y represents the original width of the rectangle. Let me write over here. Okay, in that case, what is the area of the original rectangle? Already we know the formula to get area of rectangle, that is length times width. Here the length is x and the length is y. Then area of the original rectangle is x times y, that is length times width. Okay, now we have changes in two cases. That is, in the first case, the length is reduced by 5 units and the width is increased by 3 units. So in this case, the area of the rectangle decreases by 9 square units. Okay, now let me apply the change in the first case. That is, the original length x is going to be reduced by 5 units. In that case, x will become x negative 5. And the original width y is increased by 3 units. That is, y will become y positive 3. So now this is a new length and this is a new width. In this case, the area of the rectangle is given by the length x negative 5 times width y positive 3. So this is the area of the new rectangle. Actually, when I reduce the length of the rectangle by 5 units and the width is increased by 3 units, the original, the area of the original rectangle decreases by 9 square units. That means after the two changes we have in the first case, so the original area, this xy, decreases by 9 square units. So the area of the new rectangle equals to xy negative 9. That is the area of the original rectangle negative 9, because the area of the original rectangle decreases by 9 square units. Okay, now what we can do is we can multiply the two binomials we have on the left side over here. So using FOIL method, let me multiply the first terms, x times y is xy, and now let's multiply the outer terms, x times y is positive 3x. Now let's multiply the inner terms are negative 5 on y, then I'm getting negative 5y. Now we can multiply the last terms, that is negative 5 times is negative 15 equals to xy negative 9. Okay, here we find xy on both sides of the equation. We can subtract xy from both sides of the equation. So to get rid of the terms xy on both sides, so positive xy, negative xy will cancel, the same here. So then I'm getting 3x negative 5y negative 15 equals to negative 9. Okay, here what we can do is we can keep the x term and y term on the left side of the equation. So we can get rid of this constant term. For that we have to add 15 to both sides. When I add 15 to both sides, this negative 15, positive 15 will cancel. I'm getting 3x negative 5y equals to, when I combine these two numbers, I'm getting positive 6. Okay, let me assume this is equation number 1. Now we can consider the changes we have in the second case. That is, the length is increased by 3 units and the width is increased by 2 units. In that case, the area increases by 67 square units. Okay, now the original length x is increased by 3 units and this x will become x positive 3, and the original width y is increased by 2 units and the original width will become y positive 2. In that case, the area of the rectangle is the length, the new length x positive 3 and the new width y positive 2. So this is the new area. According to the information we have, the original area increases by 67 square units for the two changes we have applied over here. So it is equal to the original area xy positive 67, because after the two changes we have applied, so the original area xy increases by 67. Okay, now we can multiply the two binomials we have on the left side over here using the FOIL method. X times y is xy, then positive 2x, positive 3y, positive 6 equals to xy positive 67. Okay, now we can subtract xy from both sides to get rid of the terms xy on both sides of the equation. So positive xy, negative xy will cancel, the same over here. Then I'm getting 2x positive 3y positive 6 equals to 67. Okay, let's keep the x term and y term on the left side. Let's get rid of the constant positive 6. For that we have to subtract 6 from both sides. So then positive 6, negative 6 will cancel. I'm getting 2x positive 3y equals to 61. Okay, so this is equation number 2. Okay, now we have two equations. In these two equations, I have to solve for the variable x, which represents the original length of the rectangle. So according to the question, that's what I have to find. So now we have to solve for x in this the system of two linear equations we have over here. Okay, to solve for x, we have to eliminate y. For that, we have to get the least common multiple of the numbers we have in front of 5, that is 3 and 5. So the least common multiple of these two numbers, 3 and 5, is 15. So that is how to make this number as 15 and this number as 15. I mean the numbers in front of y as 15. Since the y terms are having different signs, we can add the two equations and eliminate y. Okay, first let me multiply the first equation by 3 to make this number 5 as 15. So I multiply the first equation by 3. So in that case, so I have to multiply the entire equation by 3. 3 times 3x is 9x, and 3 times negative 5y is negative 15y equals to 3 times 6 is 18. Let me multiply the second equation by 5, so that when I multiply by 5 times 3, it will become 15y. So the entire second equation has to be multiplied by 5. So when I multiply this 2x by 5, I'm getting 10x. When I multiply this 3y by 5, I'm getting positive 15y. And when I multiply this 61 by 5, I'm getting 3 of 5, that is 7 of 5. So now when I add the two equations, a negative 15y, positive 15y, I'll cancel out. 9x positive 10x will become 19x equals to, when I combine positive 8 and positive 3 of 5, I'm getting 323. Now to solve for x, I have to divide both sides by 19. So when I do so, this 19 will cancel out, then x equals to, when I divide 323 by 19 using calculator, I am getting 17. So we know that x represents the original length of the rectangle. So the original length of the rectangle is 17 units. So we find 17 in answer choice C. So the correct answer choice for this question is C.